Okay, I just wanted to go over a few of the questions on this assignment with you, and I thought the easiest way to do that might be with a video. So I've got some clips of some of the questions that were a little problematic. The one thing here, the concept that you missed, be careful because I noticed that you were doing G at 22, which is not what the value is. It's actually G at 2 root 2, and so that would definitely change your answer, and it would actually make it easier for you because that can be written as 2 to the 3 halves, which is the same base as the original function, so you can solve for x much more easily there and get a more concrete value. The problem that we had with this question is when you're asked to do the F inverse or the G inverse. What you have to be careful of is knowing what the inverse is. So if you've got y equals 2 to the x as your original function, the inverse of an exponential function is a log function. So if you take the inverse of that, you're going to end up with x equals 2 to the y, and then solving the equation for y, you get y log base x of 2, or sorry, y equals base log log base x of 2. Then you're going to put in 8 as x, and so you're going to solve your equation y equals the log base 8 of 2, and so 8 to the exponent 1/3 equals 2. Okay, so you've got to do the inverse properly before you can solve for the value, excuse me, substitute in the value, and so be careful with those. All right, so on question 5, let me see what we were doing here. Okay, the first one was fine. The second one for part B, here's what we need to do. For part B, you need to factor out the 2 from the bracket before you can talk about the horizontal transformations. So in this case, we do have a stretch of 2, vertical stretch of 2, given by this value here. But once we've done our factoring, we're actually going to move this function horizontally to the right by a factor of 2, or you can call it horizontal shift by a factor of 2. And so be careful of that. You've got to factor the 2 out of the bracket first before you can state the transformation in the horizontal direction. Okay. So looking at number 6, let me see. Okay. So we got into a little bit of trouble with number B. Actually, I'll talk about the part C in a minute as well. So we have log of x squared, because that's what 2 log x means. And over here we've got 2 logs with the same base, so we can multiply them and make that into log of 36, okay? So we have 2 base 10 logs, and so if the bases are equal, then these parts are equal. And so that leads to x squared equals 36, and x equals plus or minus 6. Now, x equals minus 6 is not going to work because if you put that in for x, say here, you'd end up with a negative log. Oh, sorry, here you'd end up with a negative log, which is not possible. And so x equals positive 6 is the only value that we can actually choose there, okay? Now, for part C in that same question, you kind of had the right idea. One of the mistakes that we made there is that 81 is actually 3 to the exponent 4, not 3 to the exponent 3. And if I rewrite all of these things as a power of 3, then this is going to be 3 squared for 9, and it had the exponent of x plus 2 before, and then I have 3 to the x minus 2. So if we simplify this a little bit, we're going to get negative 3 to the 4x times 3 to the 2x plus 4, we need to multiply there. And if we use our power rule for logarithms, if we're multiplying powers with the same base, we keep the base the same and we add the exponents. So I actually have minus 4x plus 2x plus 4 equal to 3 to the x minus 2. So if the bases are the same, then the exponents must also be equivalent. So this is the expression that you end up needing to solve. And so I guess we get negative 3x equals negative 6, or x equals 2 there. Okay. The only thing that you'd have to do when you get your values when you're working with log and exponential functions is always make sure that they make sense back in the original question. And in this case, it's fine because you don't have any logs that will end up being negative with this negative, with any of the values that you get. But if you have a log, a root for a log equation, you should always go back and check to make sure you don't get a negative. Question D is kind of neat because you have different bases, and we can do this, but it's a little more complicated. When we take logs of both sides, we're going to get 2 minus x log 8 equals 3 plus x log 3. So solving for x is a little more tricky. We might want to take 2 minus x over 3 plus x equal to log of 3 over log of 8. That's one way we could do it. This you're going to solve on your calculator, which I don't have handy here to tell you what value it is, but it's going to be a decimal value less than, excuse me, less than 1, I believe. Wait a minute, maybe I can solve for you here. So if we have log of 3 divided by log of 8, 0.53 approximately. So 2 minus x equals 0.53 times 3 plus x. So you've got a crazy equation with decimals in it, but we can still solve it by distributing the 0.53 into the bracket and then rearranging and solving for x. All right, so here's our last question that was a little bit of a problem on the test here. We're dealing with an exponential function, and they give it to us in part A. So if there are 3,000 locusts, explain why an equation that would model the population over n weeks is given by an equals 3,010 to the n over 2. The reason that is what we want to do, what we want to do in the first equation, in the first step, is explain why this model can be used to describe the population of locusts at any number of weeks, n, okay? And so you were right that we're starting with 3,000, so that's definitely the initial amount right there. And our base is 10 because it will multiply tenfold, which means we'll have 10 times as many every 2 weeks. And so instead of doing 10 to the n, we have to do 10 to the n over 2 because it takes 2 weeks, and we're letting n actually be 1 week. And so it's not going to multiply by 10 every week, it's going to multiply by 10 every 2 weeks, and that's why we have to have the 1/2 n or the n over 2. So after 7 weeks, all you need to do is put your value into your equation. Okay, so you know what, I just realized, you'll think this is funny, that you had the right answer. I just was looking at it incorrectly when I was looking at that. So you did right with that one. That one's just fine. All right. So I thought anyway that the video might be more helpful than just typing out a bunch of things, and it might help explain a few of these things for you. You're at the midterm point in the course now because you've just finished off Unit 3, which is great. You're actually about 60% of the way through, and then the final exam, so you've got 2 more units in the final exam. But what I'm going to do is issue your midterm report right now, because I know the principal has got a load of them to deal with, and we're getting into the application deadline for the universities to have those marks sent. I'm going to mention to him when I send your report that you need it sent out to the universities. Hopefully you've already provided him with the information, which universities and that. If not, could you please give him an email or a phone call? The information is on the homepage for the school under the Contact Us section, and make sure that he's aware that you need those sent out as soon as possible, and to which schools, okay? If you have any questions or I can help with that in any way, just email me and I'll be happy to help. Thanks, Cameron.